Okay, let's look at this goodness of fit problem. And what it means is this distribution uh, different enough to say that uh, the number of births on a certain day of the week is different? Okay, so let me go to StatCrunch. I've uh, opened up StatCrunch with this data in it, and this is what I get. And I just want to point out, when you go to help, there is a student study card here that you can always access. And oh man, they don't have goodness of fit on here. So it's the contingency tables, I think, is where we're going. So let's go back to our data, and right there is goodness of fit. So I did stat, goodness of fit, and I want to do chi-squared. We're not going to do the normality test. And so the observed number is in the number of births column, and then um, the claim was that all the days were the same. So that is what we're going to click on this one. And we're going to do compute. And so as we bring this over, there is our chi-squared statistic, and there is our p-value. So if all the cells are the same, we don't have much evidence against that statement. It can happen 40% of the time simply by accident. So what I'm going to do here is I'm going to write down that chi-squared statistic, or I'm going to pull this over here. You won't be able to see it, but I will. So let's go back to your problem, and our chi-squared statistic in this problem should be 6.185. And let's check it. Okay, that's what StatCrunch told me. And then the p-value, they want rounded to 4 decimal places, is 0.40028. And so what that is, since our p-value is not less than or is not small, well, there's a significance level, 0.01. So zero point 0.4 is not less than 0.01, so we cannot reject Ho. So we're just going to look at C and D. And insufficient evidence. There's not enough evidence to reject, so we fail to reject. And that's how we do that one. Now, how might the apparent lower frequency on Saturday and Sunday be explained? Well, I would say A is going to be the better answer, because they do want to do the induced or cesarean sections Monday through Friday rather than on the weekend. And that's how you do goodness of fit. Now let's look at StatCrunch one more time. And oh, if I was going to do, let's say I think half of the births would be on Saturday, then we're going to have an expected count column over here, and then you would just check that column. And so if you have an expected number that's not the same, then you're going to compute it. Let's pull this back over so you can see what I'm talking about. So you see, when I did my table, and in your book it talks about how to do this by hand, but when I did my table, my expected count is the same for all the days. So basically what we did was we took those 379 births and divided by 7. And that's how we expect about 54 births on each day of the week. And sometimes you're given, like we expect, if this is Sunday, Monday, Tuesday, on Tuesday we would have 100, we would expect 100 births. And then on Saturdays we would expect no births. We could change this, and that would be a second, rather a third column in your data. So make sure that you look at one where not all, it isn't expected to be equal on each one of your categories. I hope this helps.